to have a profile of these people who are listening in. Okay. Okay. I am talking about this X.805 standard. Nothing technical. I guess most people will probably be. I guess the audience who attend this Hack in the Box tends to be the geeks kind rather than the people who are more in the management kind. So I suppose the people who left behind are the most probably won't understand what track 1 is talking about for Metasploit. But Metasploit is interesting, but I guess probably another reason why you're here is also because you probably have heard of Metasploit before. So anyway, let me talk about X.805. Today, my speech will be very short. In fact, I'll take about 30 to 40 minutes of my presentation. I'll explain to you what is this X.805 about. It's actually a standard that's developed by docents and something that is very useful for organizations these days. I'll tell you what is it all about, its relevance, and the future. Okay. Before I start, can I just have a show of hands? Anybody who has heard of X.805 before? Anybody? Yeah, just one guy. Can you tell me what is it?
Well, I don't really know what it is. I just know it's using an NGN security concept.
It is, yes, it's related, but it's nothing to do with NGN. But NGNs can make use of this standard to do some stuff. Okay? Now, can anybody on hand give me a show of hands? Can anybody name me any network security standard out there available? Anybody? Okay? I suppose you probably would not have heard of anything like a network security standard out there. Okay, today I've been doing consulting for a lot of companies. Many people ask me this question. They say, Meng, I have ISMS, I have this standard, I have application security standard, OWASP standard and stuff like that. Why isn't there someone who developed something which is very fundamental as network security standard? I said, yes, there is. Okay, and today my presentation is talking about this network security standard. Okay, now as of today, there isn't a single standard before what I'm going to say, okay, that really guides an organization on how to secure the network. Everybody today, when they secure their network, okay, they have their own particular way of perceiving and the way of how to approach in their own approach in securing the network. Okay, what they usually does is traditionally, when they design the network, they may engage auditors or they may engage consultants to come and review their network. Okay, so the checklist method, which most people are pretty familiar if you're in those banks or in the government area, that the auditors usually like to do is they have a list that says that, oh, your network must have this, your network must have that, your network must do this. If you don't have this, you fail the checklist and you fail the audit, blah 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 blah. So the checklist method, I have actually received quite a lot of feedback from people is that it does not really provide any value to the customer. So reason, basically two things. If you look at the first point, okay, the same control cannot be applied, okay, in a similar manner for different organizations. And second thing, it's not dynamic enough to address for ever-changing technology. Let me explain these 2 points in details. I have 2 extreme kind of networks that I've seen in my life. Okay, the most extreme one end is the banks. The banks have super duper technology that secures every single thing from the database field to the database, to the OS, to the applications, to the network, and so on and so forth. Okay, so that is one extreme end. I have the other extreme end, which is the telecommunication industry, which basically the service provider, which basically don't like to secure anything. Anything that they secure affects the customers. So if you look at what we call the security principle, we have this kind where the bank is deny all, allow some. In the telco in the network is allow all, deny some kind of principle. So if you are going to use a single checklist method, which people always like to engage people to do a checklist, do you do point 1 to point 50? I can tell honestly that is not a very relevant field. Everybody's networks are different. There are big networks, there are small networks. You use the same checklist for 50, okay? Big organizations can do it, but how about small organizations? So the checklist method being static are not flexible. Okay, so this is for the first blue point. Now, if you are going to use the checklist, you better review your checklist every now and then because technologies move very fast. Okay, I was still talking to some people on talking about vulnerability management in my booth about 8 years ago. I still remember networks was like 1 megabits per second network was considered very fantastic. Today we're talking about 10 gigabits switch kind of environment. Okay, and for the kind of environment, the kind of security threats actually change. Okay, moving from, actually last time denial of service attack was not really a concern because the infrastructure doesn't allow you to launch that kind of massive scale. Today with people with broadband bandwidth, DDoS is becoming so common that it's almost part of our daily life. So the point here is that technology changes so fast, and the kind of approach how you secure networks must really be very flexible. Okay, so different business requirements warrant different kind of controls. So this is where I'm going to talk about X.AO5. Why X.AO5 is a fundamentally different way to address network security standards. Okay, a little bit of introduction about X.AO5. For those people who have probably heard of Bell Labs, okay, you know that Bell Labs is actually a research arm of Lucent. They are the one who actually developed this standard. The standard itself formerly was known as the Bell Labs Security Framework. Okay, and I will talk on this Bell Labs Security Framework. Okay. It was designed and developed to address the robustness of network security framework. And take note one thing, it addressed end-to-end network security. That means it just doesn't talk about just infrastructure. It really talks from the layer 2 all the way down to layer 7. Okay, it will help organizations to look from all the way from layer 2 to all the way layer 7. So what kind of networks are we talking at? Okay, the same standard can be used to secure things like wireline voice and data, which means that basically things like Ethernet environment, okay, or the telecommunications network, GSM whatsoever. Wireless can be again 802.11 or GSM or UMTS and stuff like that. Okay, we have optical networks and also converged networks, which is something like an IMS environment. IMS which is for voice, video, and data time. Let me try out something. I like laser pointer. Okay. Now, it can be applied to all types of service provider and enterprise networks, and it can be applied across all layers of the protocol stack. Now, this is very important. The standard that we develop, okay, must be, okay, useful for all different kinds of networks, even for small networks, okay, for just a probably 5-user environment to hundreds, thousands of different heterogeneous networks of different kind of mixture all put together. Okay, so this standard is that flexible. Now, I'm going to show you just an example. If today you are running a network, or you're designing a network, or you're an auditor, or you're a consultant, or whatsoever, okay, given a network like this, okay, what is the best way to determine, okay, how to secure such a complex network like this? Okay, from the perspective, from the management, to the technical people, to the end user and stuff like that. How do you actually secure such? How do you know even when to start, where to focus your efforts, okay, to secure such a big network? Okay, now I will put this diagram here for you to think about, because later when I start to talk, okay, I'll come back to this diagram again. So I want to share with you this diagram is that today's networks are designed like that, okay, with things like a core network that is connected to different kind of sub-networks, okay, across remote networks and probably internet networks and business partners networks and remote access networks for end users or remote users kind of thing. So you basically have such a complex network these days, and these days networks like this are not uncommon. Okay, it's really not uncommon. So if you are going to use what we call the static way of using the checklist method to secure the network, you probably start off with every single network must have firewalls. Okay, every link points here must have firewalls. Okay, is that practical? And then they say that you must start securing this network and this network and this network and this network. Basically, most people will think that you must focus on everything. Okay, now you can focus on everything, but always one thing when we do consulting and we do auditing is that always put in the right amount of effort to do the right thing. Okay, so X.AO5 can actually help you to focus, look at your network carefully, and to put in the right amount of resources to secure network. Okay, I'll come back to this diagram later, because when you haven't heard the rest of the presentation, you don't really know what I'm talking about. Okay, this is going to be a lecture, slide 1. Okay, for people who hate lectures, okay, this is the time to switch off your brain. Okay, so anyway, you can freely download this information about X.AO5 from IQT website. But for a start, let me guide you all how to understand this standard. Now, Bell Labs Security Framework defines security threats. What do you mean by security threats? A security threat is defined as something, okay, a framework that defines Okay, this broad security framework, okay, addresses security threats by identifying issues that need to be addressed in detecting, correcting, and preventing both intentional and accidental threats from inside and outside the network. Basically meaning everything. Okay, so this definition is very all-encompassing. Okay, we define security threats to be so. Now, there are 4 kinds of threats that is defined in this framework. Okay, interruption, interception, modification, and fabrication. Just to go through a quick one, I think the interruption things like you prevent the person from using certain things. DOS is something like interruption. Interception is more like sniffing of data or sniffing of information. Modification is affecting the integrity of information, and fabrication is you create false information, also some form of integrity issue. Okay, so in the Bell Lab security framework, okay, there are 4 different kinds of threats that are being identified. Now, in this security framework, we also define this thing called the security layers. There are 3 security layers consisting of hierarchy of network equipment, facility groupings, and blah 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 blah. Okay, I let you all read because I'm not the kind who like to read off from the slide, but I like to more explain to you what are they. There are 3 security layers defined in this framework: infrastructure, services, and applications. Let me explain in this diagram. In my eye, through the framework of X.805, every network can be broken down into 3 components, which is known as security layers. The first part is the infrastructure. Example, if you don't have a network, what's there to run? Correct? You need a network, you need an infrastructure so that network services can run on it. Okay? You need a service. Okay, you need a service to run on the network. Now, what do you mean by service? When you first put in a laptop into a network, okay, you know what's the first thing your laptop do? Anybody? When you first plug a laptop into the network, you know what's the first thing that your laptop do? Anybody? What?
DHCP discovery.
Correct, DHCP. Okay, DHCP is a service. Without DHCP, so what if you plug your laptop inside the network? Nothing happens. You have to manually assign an IP address. Okay, so the DHCP is a very fundamental thing. It's a service, okay, that powers, okay, that makes your network useful. And that's where the last one, where all your applications on top of this service can then work properly. Okay, make sense? Make sense? Okay, any questions so far? Okay? If you violently object what I say, raise your hand. It's okay. This is a standard, okay? So if you think this standard is wrong, it can always be changed, okay? Okay, no questions? So, to put it in this way, in what we believe, every network are potentially susceptible to the following 4 kinds of threats, okay? So, and because every security layer could have vulnerabilities that could expose them. For example, if your DHCP is coded poorly, okay, people can make use of DHCP to compromise OS, okay, affect the protocol stack in your operating system. Or, for example, in your infrastructure, okay, if you don't secure your router, okay, people can change the router configuration, affect the routing information and stuff like that. So, every security layer could potentially have vulnerabilities that can be exploited by the following 4 kinds of threats. So, infrastructure security layer, okay, in this diagram you can see is the first example, things like what constitute an infrastructure security layer? Individual routers, switches, servers, you know, point-to-point WAN links, Ethernet links, wireless links, whatever links. Anything that is part of the network infrastructure. Now, services security layer, okay, are things that services provide to end users. From the telco network point of view, you have things like frame relay, ATM, IP-based networks. For the wireless industry, things like Wi-Fi, WiMAX, and VoIP, QoS, and stuff like that. All these are the services. Without all these things, whatever running on the applications will not work properly. Okay, so the application security layer consists of the end user applications, which is things like web browser, okay, directory assistance, email, and e-commerce. Now, as you can see here, the security layers are really, okay, a network really consists of a hierarchy of equipment, okay, facility groupings. So each of them has unique vulnerabilities, threats, and mitigations. And in this case, this security enables service security. Okay, so the security of the infrastructure, okay, really enables the security of the services, which really enable the services of the application. Now, what it really means is this. It means that if you are compromised at this layer, everything else above fails. Okay, if you are compromised at this area, everything above all fails, and so on. So this is what you mean by the last line. So once you understand this, okay, you can start to break down a network into what we call very separate components, where you can put in the right amount of controls to secure them individually. Okay, this is one thing that most people does not really realize. They see the network as one component, okay, and they try to do everything in just one step kind of thing. So you can't really do that, because really a network is broken down into 3 different kinds of services. Now, in the definition of this framework, now we have this thing called the security planes. Now, what is really security planes? The security planes represent the activities that take place on a network. Now, just now earlier on, I talked about a network has 3 kinds, okay, of really components. Now, what I'm saying is that in this network, there are really 3 kinds of activities taking place in the network. Okay, they are management, control, and end user. And the networks, all networks today should be designed in such a way that the events on one security plane should be kept totally isolated from the other security planes. Meaning, in layman terms, what I do at the end user should not affect the management. Okay, what I did at the management level should not affect the end user. Okay, I'll come to this example later in the next slide. Now, in this slide, imagine we have this security layer, and each security layer has different kind of activities going on. So we have the end user plane, control plane, and the main plane like this. Now, what does the management security plane really do? Okay, they are responsible, okay, for things like management, provisioning of network elements, the services, applications, everything. Okay, and the implementation can be in-band, out-of-band. Okay, so it's really the management activity. Things like management activity will be things like connecting to the router and making router configuration and stuff like that. So this is a form of management action, and you don't do this every day. Okay. The second plane, control plane, are really activities that enable functioning of the network. Things like ensuring the machine-to-machine communications works properly. Okay, so this plane really is more like an activity that you put in place to make sure that the services in the network are running smoothly. Okay, and the last one, end user security plane, are the people who uses the network for their day-to-day functions. Okay, things like email, okay, web browser and stuff like that. Okay, so the end user plane is up there. So the security planes represents the activities, and each plane is applied to every security layer to yield what we call the 9 security perspectives. And then each security perspective has unique vulnerabilities and threats. Okay, now this is all the definition. Okay, roughly you know what I'm trying to say. Maybe you don't. It's okay, because when I first learned about X.AO5 2 years ago, I can tell you, wow, the word security layer, security plane are some don't know what bombastic lingos and that I was then trying to digest what it really means. So all you need is an example. All you need are examples, not is an example. Okay, so before I go on to the examples, let me talk about X.AO5. Now, X.AO5 is not a Bell Labs framework. What happened is that Bell Labs actually submitted this security framework to ITUT back about 4 years ago. Okay, back about 4 years ago. So before we submit, we actually submitted this standard to these organizations, and they have proved and validated that this framework actually helps them to see the network design in a much clearer and consistent manner. Okay, so let's go on to talk about transition. Because it's proven, okay, we have actually submitted to ITUT for ratification. Now, ratification means that every members of the ITUT must agree that this is a useful standard before it can be ratified as a standard. So certain changes was made, and one of the changes made was actually we actually associate the threats according to the threats defined in the ITUT X.800. Okay, for those people who really want to know the real in-depth, okay, security definitions. Okay, don't look anywhere. Look at ITUT X.800. X.800 defines very, very clearly, okay, how threats affect from one association to another association. Okay, and it defines very clearly what can threats do. All the actual definitions are all there. Okay, I really urge all of you all to try your hands to get hold of this standard. Okay. Now, the 4 threats have been renamed, and then there's a new threat added into the framework. So, now, when we submit this standard, okay, it's no longer called the Bell Labs Security Framework. It has been officially named as the Security Architecture for Systems Providing End-to-End Communications. Okay, so, and yeah, it's ratified by ITU on October 2003. So, this is my favorite diagram. In fact, when I talk about X.805, I always show people this diagram. Okay. Now, what really changed is actually these 5 threats, as you can see here, and you can see this thing called the 8 security dimensions. Now, what this diagram really means is that every network which has 3 different security layers under 3 different kind of security planes can be threatened by 5 different threats when they are vulnerable. So, 8 vulnerabilities can exist in each layer and each plane. So, the only way to protect yourself against the network is to have what we call these 8 security dimensions to mitigate all these 5 risks. Okay, so how does it work? This is how it works. Before we talk about the security dimension, let's talk about the threat model. In the X.800 threat model, there are 5 different kinds of threats: destruction, corruption, which was more formally known as modification; removal, which was a new term defined here; disclosure, formerly interception, and interruption. And threat fabrication really is incorporated as part of corruption. Now, this is the diagram how it looks for X.800. Okay. Destruction in X.805, or rather X.800, is defined as the destruction of information. So if you look at this diagram, it means that basically people who try to access the information can't access it because it's totally gone. Okay? Corruption is an attack on integrity, where things like middleman and middle attack could modify information. Okay, maybe the legitimate user is trying to access this server, a guy in middle, okay, corrupts the information that's being sent to the server. Removal is different from destruction in the sense that it's an attack on a vulnerability in this way. The user tries to connect to the server and an attacker prevents him from connecting. Now, one example of an attack like this will be things like TCP reset attack. Okay, someone send a TCP flag, okay, and I send a TCP reset flag to both systems to cut them off. Okay, so this is a removal attack. Disclosure attack is an attack on confidentiality, which basically does nothing but sniffing on the information. Okay, so this is disclosure. And lastly, interruption. Interruption, an attack on vulnerability is actually, okay, that the whole entire network has been affected. Okay, this whole thing is really gone. Okay, the information is still there. The infrastructure that provides the access for you to access is no longer there. This is different from destruction, and interruption and destruction are really 2 different things, as you can see. Okay, so these are the 5 different kinds of threats. And if you can look carefully, every kind of threat affects some form of the CIA. Okay, availability, integrity, and confidentiality. Okay, so I hope this is a very clear. Do not dispute about this because X.800 has been around for more than 10 years. Okay, validated by many security professionals all over the world. So I think basically this looks quite sensible to me. So based on these threats, based on these 5 security threats, okay, we have what we call a security dimensions that is specifically set to address a particular aspect of network security. Now, X.805 identifies 8 sets of security dimensions that can protect against all threats defined previously, as I said in my previous diagram. Okay, it can be applied to the network applications and the end user information. So this is how it looks like. First one, the first security dimension talks about access control. Okay, access control doesn't really talk about C, I, or A, but it talks about the triple A: authorization, authentication, and audit. Okay, so so access control, as you can see, okay, is one way to limit someone to access the network element services. Okay, so that's one of the access security dimension. The second one is authentication, which provides proof of identity. I won't go into this because they are quite straightforward terms that you encounter every day. Non-repudiation. Okay, Non-repudiation is a very interesting security dimension. Until today, most people doesn't see the importance of it. And one of the important things in network security, okay, I can't emphasize many times to customers, okay. A lot of times people don't see the importance of non-repudiation. And today, things like phishing, okay, phishing, you know phishing? Phishing? I'm not talking about that phishing, I'm really talking about some other kind of phishing, you know. Phishing are really a form of repudiation attack. Okay? How do you prove that you are really accessing the site? Or how do you prove that you're really talking to this user? Okay, I can assure you one thing, 90% of the people that I deal with, nobody understand about this non-repudiation kind of control. Okay? So non-repudiation really refers to things like digital signatures and system locks. Okay, today most of the controls put in by people, you know, things like access control, authenticate, they emphasize on that, but things like system lock and digital signature, nobody talks about it. Just now, Fabrice talks about application attack and that developers never look at logs. Okay, non-repudiation is really one way of ensuring that when things happen, it really happened, and you can see for sure that something like this has taken place, so that you can do something about it. So, as a form of threat mitigation, okay, non-repudiation is a very useful way as a form of what we call protective and detective control. Okay. Data confidentiality, I shall not talk about it. It's very straightforward. Okay, basically how to ensure data are confidential and remains protected from hidden eyes, from public eyes. Okay, one way to mitigate this is through encryption. Communication security is different from data confidentiality. It deals with point-to-point communication. How do you ensure that this point is talking to this point? Okay, in technology today, what can be done is things like VPN, MPLS, okay, VPN connections that they really can guarantee that if you connect to this point, it is really this point and no one else. Kind of thing. So communication security today is also one of the threats that service providers are very worried, where people can actually redirect networks routings from one area to another area without knowing what happened. Okay, so this is one of them. Data integrity. Data integrity, again, for most people who study about simple fundamental information security study, okay, integrity is basically ensuring information are not modified when they are transmitted. So we can do that through MD5, digital signature, antivirus software, whatsoever. Okay, MD5 is just an example. Okay, you all know that MD5 is not secure. Are you aware of that? Yes? No? Anybody can tell me, is SHA-1 secure or not? Debatable. Okay, it depends on the value of information. Okay, now I like to talk about all these little extra things so that to educate the people, you know, there are some interesting things that have happened. Availability. I'm not going to talk about this. Management, all the management. If you are all management level here, you know what I mean by availability. So I shan't go into it. And lastly, privacy. Now, I want to spend a bit more time on privacy. Okay, the control privacy is a term that is quite unheard of especially in Asian countries. Okay, especially governments in Asian countries don't believe in privacy. Tell me honestly, how many countries in Asia, Southeast Asia, has a privacy act? Anybody can tell me how many? The answer is very simple.
Try governments in general.
Sorry?
Try governments in general.
The answer is very simple. There are zero. Okay, zero in Southeast Asia. Okay, in Southeast Asia, privacy act is virtually unheard of. Even in Singapore, they are trying to do that. And from my understanding, people like the Ministry of Defense and Ministry of Home Affairs are not very keen on having a privacy act, because privacy act really implicates things like what we call the act of protection against terrorism, stuff like that. So this control privacy really because it was developed in US, and you know US and the European countries are very pro-privacy. And when they define privacy, what they are saying really here is that it is different from data confidentiality. Okay, let me give you an example of privacy. If you are to transmit an information from one point to another point, okay, let me give another example about privacy. Now, if I take part in a lucky draw, okay, if you ask me for things like my personal registration number, okay, is that necessary? Do I need to disclose my personal registration number in order for me to take part in the lucky draw? Is it other ways for me to disclose other more public information that could ascertain me without disclosing something as personal as this. Okay, that is what we mean by privacy. Privacy and data confidentiality are closely related, but they are not the same. So this is very important. Okay, anybody still very confused by my example? I will want to spend a little bit more effort because coming from Asian countries, when I say the word privacy, people don't understand what I'm talking about. What privacy? Okay, so anybody quite clear on my example? Do I need to give one more example?
I think you should think about the NSA before you think of Malaysia.
NSA. Well, when George Bush takes over, the meaning of privacy is lost. Okay, I think the only place that I know where privacy is still highly valued is still the EU. Okay, EU really values privacy. Okay, so privacy really here it means that any form of unnecessary kind of information should not be transmitted. So things like if there is a way, okay, I give an example. In SSH, those people who are familiar with SSH, okay, you will know that if you transmit username and the public key, the communication established shows absolutely nothing about what username is transmitted across the network. Okay, that is what we mean by privacy. Okay, in the communication link, okay, there is no such thing that happens. Another way example is that I can't think of, okay, if you do, let's say for example, if you do logging, okay, other than logging where the IP address comes from, you don't lock down what the person does and stuff like that, okay? Because if you do lock down what the person does like that, for audit purpose, yes, you can do that. But if the information is compromised, okay, a lot of things can be gleaned out of it. So that is what I mean by privacy. So privacy and non-repudiation, okay, sorry. Privacy and non-repudiation, okay, sometimes have a form of conflict, okay? So it's really finding what we call a balance, okay, in putting the controls in place. Now, each of these security dimensions are then applied to each security perspective. Again, all the little points. You know, the one thing I hate about explaining X.AL5 is that you must explain all the key terminologies first before you can put them all together. If you put them all together and explain, it's very hard. So please bear with me for a while. Okay. Now, this diagram shows you how the 8 security dimensions mitigate the 5 threats. Okay, I give you about 10 seconds to just look through, okay, and you can see interestingly, that most of these controls can mitigate things like theft or removal. And non-repudiation, okay, as you can see here, non-repudiation is the only control that can protect against all these things, all the threats. Okay, so thus proving one thing, okay, lock is something very important, okay. Digital signature and confirmation, stuff like that, are very important because it can prevent a lot of problems like this. Okay, so things like privacy only prevents only just one area, disclosure of information, and what else? What other interesting things? Yeah, so that's about it. Okay, and you can see for interruption of services related to availability. Okay, so quite a very straightforward diagram. I'm not going to go down too much into it. Now, if you want to put this X.AL5 into the picture, how can I use X.AL5, okay, in really to secure my network? Understanding the concept means that when you first define and plan a network infrastructure, okay, and the necessary policies and procedures, or even deploying the right technology at the planning stage, you can use this standard. You can use this standard during the implementation stage. Okay, and you can use this standard even during the post-implementation stage. Okay, so this standard is very flexible. Okay, I'll come to this more later. Okay, this is going to be the one of the toughest part of the X.AL5 explanation. So you are aware now there are 3 security layers, and you are now aware of 3 security planes, the activities. Now, if you create a matrix like this, there are actually 9 modules, okay, that is being developed in this table. Now, these 9 modules really means that each module tells you, if you want to secure your management of your infrastructure, there are 8 security dimensions, 8 different kind of controls to consider in this module 1, okay? And each of these modules, all the 8 controls are all totally different between one another. Okay, that is what it really means. So what it really means at the end of the day is because there are 8 of them and there are 9 modules here. So altogether, there are 72 security perspectives that you have to consider for the entire network. Okay, that's what really it means. Now, if I were to come back to this diagram again, just now earlier on when you see the diagram, right, it was very colorful. But now I make it dark and I want to focus on the color codes. Can you look at the color code here? Management plane, control plane, and user plane. Okay, now, through this example, I will look at the network like this. Okay, anything that is in red, okay, is within my charge. Okay, it's within my charge. I am the, let's say for example, I am the CIO. Anything within this network diagram is my charge. And because this 1, 2, 3, 4, 5 are really more into the infrastructure and more into the management aspect, I know that I only need to apply the management controls on these relevant networks. Anything that's outside here, since it belongs to someone else, I do not focus on it. Okay, and I scope my work down to focus my network controls on just here and upwards. And because all these networks deals with applications and management of services and stuff like that, okay, I have the green and the blue, which is here. Okay, which means that for these subnets, okay, I have to put in a little bit more controls, okay, to focus a bit more to secure networks like this. Okay, so this is how really it's applied. So the point here is that when you first see the diagram, it looks so complex, like almost like you have to do everything for every single subnet. Not really. Okay, in this case, through this X.805 application, this is how you identify what is the important things to focus on. Okay, I will show you a table later. This diagram is just to give you an example. Actually, I'm not too keen on going through all this module 1, module 2 and stuff like that, but just to give you some examples. Some of the examples about what each module does. Now, for example, the objectives of each module have certain kind of objective. Like for example, module 1, infrastructure management, is concerned with securing operations administration of the individual network elements and stuff like that. Now, I give you an example what I mean by module 1. If you have a router, okay, a router is really a part of the infrastructure, and the only time you use it is because you are managing it. A router is not used by end user. Okay, so now you have to think, how do you secure a router considering the 8 security dimensions? So the module 1 has the following key controls and objectives to tell you how to secure this particular area. I will skip through some of these things because it's very dry and I don't like to explain this when there's no example. So I give you another example. Module 9, applications and user. Now, an email program is an application. Okay, an application which is used by the end user. So considering because it's an application, so you have to consider how to secure things like user data. Okay, maybe like things like how do you protect the passwords. Okay, your application must first protect the password, first maybe like mask out the password entry, stuff like that, and then do the encryption right at the application layer before it transmits out, kind of thing. So, so this module is, the controls are entirely different from how you secure a router. Okay, so to give the best example, I always like this for the coming next 4 examples. This example will show you how do you secure a network in different application contexts. Let's start off from internet service provider. Now, every internet service provider definitely have a router, distribution switch, maybe RAS. Okay, now these are part of the infrastructure and they are to be managed, so they are here. Okay. The protocols used for the infrastructure, okay, that powers the network, okay, makes it possible things like BGP or OSPF. Okay, and lastly, things like management software and email protection software are really part of the infrastructure that manages the entire network and then is used by people like administrators to protect the network. Okay, then we have the other end here, applications. Okay, things like email accounts and web pages are really at the management perspective. The protocols used by the applications are things like SMTP, POP3 or HTTP, and the end user are really the client software itself. In between, services. There are 3 different kinds of services. The management service will be things like Radius and SMP. These are really the things that manages the network from a protocol point of view. DHCP is a control service. Okay, without this, basically everything doesn't work here. Okay, so it's really in the center. And lastly, end user. Okay, end user may use things like DNS, okay, finger who is. Okay, this make use of service, but really is a end user perspective. Now, if you would ask me, Meng, what does this mean when by breaking down into this table? It really means that I am going to put in the relevant resources in protecting this. The controls that I put in this really is different from the controls I put in here. Okay, to give an example, let's say BGP OSPF is dealing with routing information. Okay, so routing information are very sensitive. So I have to consider how to make sure that only authorized routing activities, routing configuration could take place in here. Whereas for these protocols, okay, I can't really secure it because it's used by end user application, and it really depends on what application you use. So maybe what I could do is, in order to prevent people from exploiting the protocols, I limit the protocols to certain kind of access. For example, I do not allow people to use port 25 SMTP or port 110, port 3 service. Maybe I'll force them to use secure SMTP or secure POP3, okay, when they access their network, kind of thing. Okay, so this is just an example. The controls that you focus on are different. Another example, this is a probable MNC environment. Now, MNC environment, okay, almost similar to the ISP, but the things that are different is things like this. Okay, they are using RIP. They don't use things like OSPF or BGP whatsoever. Okay, and they probably be using things like IPsec for VPN access and stuff like that. Okay, and then they probably use things like VoIP and database encryption and stuff like that. And you can see they are totally different. Okay, and because they are totally different, the way how I approach in recommending controls to secure each of these relevant modules are different. Okay, because first of all, I must ask myself, if I'm an ISP, today if I'm ISP, I'll tell you the right way to approach to secure your environment is to start from here. Because really, as an ISP, your business is in the infrastructure. Whereas for the MNC, okay, the infrastructure, okay, is important. But what really is more important is the applications and the services that you use in your environment. Okay, so you will start focusing on here first before moving down, kind of thing. Okay, another example, ASP. An ASP provides and manages applications for people. Okay, so they are really concerned with only managing this. How the users use it for all those purposes is not the ASP problem. Okay, now in contrast with ASP, I have what we call a small business company who does not own the infrastructure. They may probably outsource the network management to service providers. So their concern really is more on protecting things like this. Okay, protecting things like this from the perspective. Okay, these four examples I want to show to all of you is that because depending on the complexity of the network, depending on what business you're in, depending on what areas of network operations you're using, okay, you could focus your resources really rightly to focus protecting at the relevant portions instead of focusing everything. Imagine if a small business company has to worry about every single thing. It just doesn't make sense. The problem with checklist is that it forces even small networks to focus on everything, which is really totally not right. Okay, so let's talk about the relevance of the X.805 networks today. It's really comprehensive and end-to-end network security, and is applied to any kind of network technology. It can be applied to any scope of network function, which are all like this, and it can be mapped to existing standards, okay, which is useful for enterprise service provider and government needs. What do I mean by that? Let's talk about relevance of X.805 to 17799. Okay, for those people who have not heard of 17799, it's basically an ISMS code of practice standard. Okay, here are the 10 or rather 11 domains of the ISMS 17799. Okay, X.805 actually has now been an ISO standard. Okay, it's really 18028 part 2. Okay, in this ISO, okay, I myself belongs to the Singapore chapter of this ISO IEC/JTC1/ Standards Committee 27/WG1 previously, but now it's known as WG4, Working Group 4. Working Group 4 is now focused on network security standards from other standards. And it has been agreed at the Standards Committee 27 level, okay, that every standards that you see here, okay, now developed, are slowly being used to complement 17799 and 27001. Okay, Anybody knows that 17799 in the year 2007 will be called 27002? Anybody knows that? Don't know, right? Okay. Now you heard it from me. Okay. In the year 2007, okay, in I think it's December 2007, there will be no longer 17799. It will be called 27002. Okay, please remember this. Okay, so 27001 is the former BS7799 Part 2, and the 27002 is the 17799. And each of these standards that's being developed right now in the ISO standards are being used to help you to implement ISMS control in details. So today, if let's say the CIO asks you, okay, I want you to implement all the entire controls in place. Then you read through the section on, let's say for example, communications and operations management, and say, you must have this in place, you must have that in place. Yeah, I need all this in place, but how? How do I do that? Okay, so this control says you must secure your network, but how do you secure your network? Okay, so you can use 18028 Part 2, which is really the security framework architecture, okay, to design or to review through your network and see how you can control them better. For those people who are interested, 18028 Part 1 is in the area of security management. Okay, how do you manage your network securely? Part 3 is involved in VPN. Part 4 is remote access server, and Part 5 is Part 3 is in firewall. Part 4 is RAS. Part 5 is VPN. Okay, so we belong to what we call the 18028 family, the Network Security Standard Series. Okay, any questions so far? I have 14 minutes. Okay, let's make it quick. Now, how does the industry benefits? This standard can be used by 4 different kind of people. First, end user. Okay, people like CIO can use this framework to see where are the essential areas of network to secure, just like I showed you in the previous 4 examples. The consultant can use it as a baseline to design a secure network based on best practice, because this standard is now officially adopted, both at IQT and the ISO level. So it is useful for consulting. It's also useful for auditor to review the security design of the network by first taking a very big network and breaking them into 9 different components. And then you apply your audit perspective accordingly to each of these components. And lastly, vendor. This is very, very important. The vendor can use this to leverage, assure customers that when I sell you this product, okay, when I sell this security product or this network product or whatsoever product, it fits into one of the modules. Okay, so today most customers are really worried when they buy a product from a vendor. Okay, the vendor doesn't know much about network security. They sell the network security product in the default configuration which is not secure and does not and compromise a few things like data communication, privacy, and stuff like that. So once the vendor understands all these things, okay, they could design and configure a system to comply to this network security standard requirements. And then, the customer can be assured that, these guys know their stuff, and if they plug in this product into their network, it does not jeopardize their environment. Okay. This is really the last slide. I want to say that it has been officially adopted as an ISO standard on actually this year, 1st of February. There are more X.AO5 standards going to be produced. Okay, one is the network security certification. Bell Labs is currently doing a security certification program right now. And we are also doing a division of this network and the security features between the network, enterprise network environment and the user network environment, which is to be known as X.AO5+. I'm not sure about this yet because I heard about this standard when I was in Jeju Island this year in April. There were some talks about, because the controls that you see earlier on is really for commercial purpose. How about for end user environment, which again warrants a totally different kind of controls. Okay, so that's called X.AO5+. We have actually done a PCI mapping. Okay, for those people who are not familiar, this PCI mapping is really the payment card industry by Visa and MasterCard. Okay, we have successfully mapped the PCI mapping to 18028 Part 2, which means that if a customer, as a merchant who wants to know how secure is their network, okay, based on the PCI requirements, we can map it back to 18028 Part 2 to tell them that how secure their network is. Okay, and we're going to roll out the certification in the near future. Okay, so that really concludes much about the introduction of X.AO5, and this is really my end of slide. I understand I got 11 minutes for questions. Before I put up for questions, I just want to summarize my presentation, is that today I urge all of you to take note one thing. Networks are very dynamic, okay? The network itself, I call it, is really the identity of the organization. What the organization is really what the network is all about. And because every organization is different, every network is different, okay? And not only networks are different in each organization, the person who administers the network determines and shapes how the network functions. And really because of that, networks are very dynamic, and you have to use a kind of standard that really can accommodate to different kind of operating environments. Just as a closing note, okay, Lucent actually did a study of the security of wireless networks using this 18028, and which actually came up with a determination that WEP and WPA and WPA2, okay, which is really more secure based on these things. And our consultants actually use this to really confirm and prove that WPA2 is really more secure than WPA. Now, people say that WPA2 is more secure than WPA. Now, that is what everybody says. Prove it. Okay, so we actually use this standard to prove to people by mapping out the controls and objectives and show that because of all the compliance and the non-compliance issue, WPA2 is more compliant than WPA. Okay, so really it can be applied to a lot of other kinds of networks. Okay, so in conclusion, I thank you for your time, really for your interest in this thing. If you have any questions, I have actually 10 more minutes to answer your questions. Or Lucent actually has a booth outside, so you can actually catch me during the break time or some other time. I'll be here today and tomorrow. Okay, so any question? Yes?
You basically act in, my network has 3 levels.
Sorry. Okay.
So your basic axioms are that the network is broken into 3 levels.
Yes.
And each level has
3 different kind of activities.
Okay. And each level has what, 8 attacks?
It has 8 security dimensions which you need to consider to security that particular plane and for that layer. The activity for that particular layer.
Okay.
Okay. So that's what it really means all about. Okay. So what I'm trying to say is that because you look at this example again, let's look through all the point again. Okay. Really what you see here is this. Okay. Depending on your operating environment, you just focus really on the relevant activities that what your business is all about. Okay, I really want to show to you is that you have only so much limited resources, and networks are different from each people. Really look at the correct place before you apply the correct controls. That's what this standard is really all about. Yeah.
Okay.
Okay. So any other questions? Okay, I didn't really expect too much questions on this because let me explain why. This is still the framework, okay? The application, I can honestly tell you, is going to be very interesting, meaning that it can be pretty complex, okay? If for those people who have played with BSS99 certification, you know how complex is BSS99. This can be as equally complex as BSS99 certification. But really, at the end of the day, is you can use this as a guide, okay? Today, you can actually purchase this standard, download it, look at it, and you can use it as a guide to think about how your network is really designed by breaking down into different groups, and then you can actually think about it. Did I do enough to protect this? Did I do enough to protect this? If I am in a bank, did I do enough at the application layer? If I am a service provider, did I do enough to protect my infrastructure? So on and so forth. So it really makes you put your thinking in the right place, okay, and with that limited resource. Okay. Yes. Any other questions? No other questions? Okay, no problem. I believe maybe you all will talk about this. Maybe it's quite hard to it's very hard to digest, honestly. So if you have time, we can really chat after this presentation. Okay?
Thank you, Mr. Meng. As he said, Lucent has the booth outside, so if you have any queries or would like to discuss anything, you can feel free to see him outside. He'll be here joining us for 2 days, right, Mr. Ching? Yes? Excellent. We would now like to introduce our next speaker. He's going to be setting up his laptop for his